Hello dear students, how are you? How's your preparation going on for the exams? Welcome to Pen and Paper Chemistry on YouTube. I've given you this flowchart regarding the preparation and properties of alcohols, and I hope that you are making full use of it. There's one reaction which I had not mentioned in this chart, and that was the haloform reaction, or more specifically iodoform reaction, about which we are going to talk today. So please make sure that you have your pen and notebook ready so that you can take down notes for offline reference. Okay, before I start with the haloform reaction, look at CHCl3. What is the common name of CHCl3? Yes, it's chloroform, right? What would be the IUPAC name of this compound? 1,1,1 trichloromethane, right? Okay. From this, what would be the formula for bromoform? Again, the common name, right? So instead of chlorine, we are talking about bromine over here. So CHBr3. What would you call CHI3 as? Well done. You will call it as iodoform. Since you got your pen and notebook with you, fill in these blanks, write down the IUPAC name of these compounds as well. These in general, so we've got the halogens. The halogens are salt formers, right? Fluorine, chlorine, bromine, iodine. These are halogens. This class of compounds are what we call as haloform, right? That means a reaction which involves the formation of these. One of these would be called as a haloform reaction, taking the name from the older system, right? Not from the IUPAC system. So I hope it makes the concept of haloform clear. And if you notice, I've written in brackets iodoform reaction because that's our main concern over here. That's what is going to lead us to a very interesting observation. If you take an organic compound, of course, I should mention the word organic compound over here, reacted with halogen in the presence of an alkali, I will get one of these haloforms. So either I'll get chloroform, bromoform or iodoform, depending upon the halogen that I have used over here. So for example, I take the organic compound CH3COCH3, react it with iodine and NaOH. I get CHI3 iodoform, sodium acetate, sodium iodide and water, right? Now, similarly, if I react it with chlorine, I'll get chloroform, the sodium salt, sodium iodide and water. Similarly, can you complete the reaction? The last one, I have left it blank for you. Please try and complete it. I hope you are writing the answer. Go ahead. So this will give me CHBr3 plus, because I've got the CH3, CH3COO, Na plus NaBr plus water. Oh, I made a mistake over there. What's the mistake that I've done? Instead of Na, what product will be formed over here? NaCl. Just like here, we are taking bromine, so we are getting NaBr. Here we took iodine, so we got NaI. Look at these reactions. Chloroform is colorless, right? It's got a strong odor, but it is colorless. Same way, bromoform is also colorless. But look at iodoform. I have marked it with a yellow color as a constant reminder that it is a yellow colored PPT. Iodoform that is formed over here is observed as a yellow PPT. That means I can use this reaction to my advantage in order to identify what type of compounds give me iodoform on reacting with iodine and an alkali, right? Okay, one question to you. Supposing I have to write the reaction of CH3COCH3. Okay, by the way, what is the name of this compound? Common name as well as the IUPAC name. Pause the video, try figuring out the answer. Okay, common name is acetone. Yes, the nail polish remover, right? And what is the IUPAC name? Propan 2-one, right? Because it's a ketone with the C double bond O at the second position, or also you will also find it written as propanone. Because it's a ketone, the C double bond O will be at the second position only. Now try writing the reaction of propanone or acetone with iodine in the presence of KOH. Yes, you know that NaOH and KOH are like very close cousins, right? Their behavior is almost similar. So write down the products over here. The next question that comes up is what type of compounds, organic compounds will give this reaction. So here I told you that we take an organic compound and react it with halogen. But what type of compounds in particular? We know that organic chemistry is very, very specific. So remember over here there are two categories of compounds which give this particular reaction. Compounds having CH3CO group and compounds having CH3CHOH group. Why do compounds having CH3CHO group are able to give this reaction? Because under the conditions of the reaction, they actually get oxidized to the CH3CO group. We have seen that in the case of what functional group is this? Yes, it's an alcoholic group, right? So we know that alcohols are oxidized to aldehydes, right? CH3CO. But do all alcohols give this reaction? No. Only alcohols having the CH3CHOH group. So let's tick mark. Which ones of these will give us the reactions? Which one will not? CH3COCH3. Yes. Obviously, we've written so many reactions. Yes, this gives us. Okay, come to the second one, CH3CHO. Will this give the iodoform reaction? Let's expand the structure. CH3CH double bond O, right? So that means this compound has the CH3CO group, right? And that is what we want in a compound in order to be able to show the iodoform reaction. So there goes another tick. Okay, look at the next one. No. Don't jump to conclusions. Expand the structure and then tell me the answer whether this will show the iodoform reaction or not. CH3, CH2, CH double bond O. Look at it. What do I have? Do I have a methyl group? Is there a methyl group attached to the carbonyl group? No, it's an ethyl group, right? So will this particular compound give us the iodoform reaction? No. So let's strike it off. Okay, try the next one. Look at the structure and see. Do you have the CH3CO group anywhere or CH3CHOH group which can be oxidized? Let's look at it carefully again. Yes. We have the CH3CO group here. So you are able to relate, right? So should I put a tick over here? Okay. Now look at the next one. Be very, very careful. Does it have the CH3CO group or CH3CHOH group? Look over here. CH3CO, because here it is not bonded It is like CH3, CH2, C double bond O, CH3. So it's again a ketonic group, a methyl ketone. That means C double bond O, CH3 group is there. So what do I do? Yes, absolutely, put a tick. Okay, now let's see, I'll give you one more. Tell me CH3, no, C2H5OH. Will it show iodoform reaction or not? Look carefully. Look carefully, draw the structure, expanded structure. So CH3, CHHOH, right? Look at what we've got over here. We've got a CH3CHOH group which can be oxidized to a CH3CO group, right? That is what we said at the beginning. Compounds having the CH3CO group or compounds having the CH3CHOH group, right? So in the case of ethanol, we've got the CH3CO group, right? No, sorry, not CH3CHCO group. We've got CH3CHOH group, which will be oxidized. So what do I do? Do I put a tick? Yes. And that is why you'll appreciate why this reaction was taken up in alcohols. You must be wondering all the while, why are we talking about aldehydes and ketones in the chapter of alcohols, right? Okay, let's do one more. Tell me, CH3OH. Will it show iodoform reaction? CH3, CH2, CH2OH. Propanol. Will this show iodoform reaction? What do? I strike it off? Yes. What do? Do I strike it off? Yes. Okay. Okay, look at another structure that I've drawn over here, right? It's a secondary alcohol. Do you think this will give us the iodoform reaction? Look carefully. What have we got over here? We've got the CH3CHOH group. Remember, we said that secondary alcohols are oxidized to ketones, right? And that will again bring us to the CH3CO group. Correct? That means what do? I put a tick or a cross? Correct. And there we have the concept of iodoform reaction. Now we come to the writing and completing the equation bit. Of course, the most important bit, right? Okay, now try writing the reactions for these. Make sure that we tally the reaction products. So we've got iodoform, sodium formate. Why? Because look at the original compound. It's not CH3COCH3. There is no extra methyl group over here. There's hydrogen. So with the result, you will get HCOONA over here. That is sodium formate as the product, right? Okay. Similarly, with ethanol, look at the products which are formed. And by the way, be very, very careful. It's CHI3. Many a times, students in a hurry write CH3I. No, that is wrong. It's CHI3. CH3I will be iodomethane. It will not be triiodomethane. We are talking about 3 atoms of iodine attached to carbon and hydrogen here. So all in all, what is iodoform reaction? How do you define it? Teacher, you've taught so many things, but how do we define iodoform reaction? How do we write for the exam? When a compound containing CH3CO group or CH3CHO group reacts with iodine in the presence of an aqueous alkali to form pale yellow precipitate, pale yellow crystalline precipitate of iodoform, which has a penetrating sweetish smell. You know, the smells like the smell that you feel in hospitals and dispensaries. So that kind of smell is related with iodoform, and that is why you can connect that it is used as a disinfectant and antiseptic. So it helps us to distinguish between different types of ketones, aldehydes and alcohols. Not all alcohols, but of course alcohols having the CH3CHOH group. Should I ask you a question? Can you identify or can you distinguish between CH3CO, CH2, CH3 and CH3, CH2, CO, CH2, CH3? How will you distinguish between the two ketones? See over here, both of them are ketones. Oh, yes. Now you know the answer. I am so glad. Yes, this first one will give us the iodoform reaction because it has the CH3CO group. Well done. I am so proud of your learning and the fact that you are actually doing self-study. You are educating yourself. Wonderful. Well done, and keep it going. Stay connected with the channel Pen and Paper Chemistry because we have a lot to do together, right? But at the same time, don't forget to take care of your good health as well. See you in the next topic.